I am Anil Kumar, and I hope this series has helped you to review the topic equation of lines. So we have already dealt with few questions on equations of lines relating to R2, and now let's move on to R3. The question here is, a student missed the first lecture online and wants to understand how the following set of three equations related. Identify the object and make him understand the meaning of t and its significance. Now, we can give a lot of details. It's an open kind of question here. So let me start by saying that this is equation in symmetric form, and it actually represents an equation of line in space R3. Now when we say x equals to 2 minus 10t, y equals to 4 plus 10t, and z equals to 3 plus 20t for every t belonging to real numbers, we are actually writing the equation in its components forms, the x, y, and z. So it actually says that there is a line which is passing through the point, and the point is 2, 4, and 3 plus scalar multiple of the direction. So the direction is given by minus 10, plus 10, and 20. Now as you know, direction, it can be simplified. So it's equivalent to saying that the line is going through the point 2, 4, 3 with the direction. We can divide by minus 10 and get 1 minus 1, 2, right? Now that is the equation of the line we are talking about, and in R3 we can write this as R equals to this. Now the beauty of this is that we just say this is the point 2, 4, 3. So let us say this is my point 2, 4, 3, and the direction is 1 minus 1, 2. That means 1 along the x-axis, y-axis minus 1, and then 2. So kind of, let's say it moves in this direction, right? So t values, when you multiply by any number, which is a real number, will give you points in this direction, and it could be negative 2. Do you see that? So that is how it represents the whole line. So t here is called the parameter. So t is the parameter. So whenever we are trying to define some variable with respect to another variable, then we call that variable as a parameter. So what is a parameter? Parameter is the other variable which helps us to define another variable. So it's relating to variables, correct? So that is the meaning of parameter. And you should also note that line is one-dimensional. Since line has one dimension, we really need a parameter to define that particular dimension, right? So now I hope you understand that t helps us to define a line. In fact, map each and every point on this line, since t belongs to real numbers. So if I multiply this direction by, let's say, 3, it means that from the original point which I am considering, move 3 times this space or in this direction. So 1, 2, 3, like that. Now that number t could be 0, plus, minus any integer. It could be any real number for that matter. So when it is any real number, then all the points on this line are mapped. I hope you understand and appreciate how we can represent a line with the help of this equation. Now we can actually translate it into different forms. The one which I have written here is called the vector equation. And we can also write this in symmetric form. The way to do it is like this: isolate t. So if you isolate t, what do you get? From here, if you isolate t, you get x minus 2 divided by minus 10. And that is t, right? If you isolate t from the second component, the y component, then you get y minus 4 divided by 10. And if you do the same for z component, you get z minus 3 divided by 20. Now all these are equal to the same parameter t, so they are all equal. And this form of equation is called symmetric equation, right? So this is symmetric. And let me tell you here that we really don't have any Cartesian or scalar equation in R3. The reason is the Cartesian equation is always with respect to normal vector to the line. But if we have a line in R3, then there could be many normals. Do you see? If this is a line on this page, then all the vectors which are going perpendicular to this page will be normal. Let's consider the other way. Let us say our line is shooting out of the page, right? This dot representing the line which is shooting out of the page, then every line on this page will be perpendicular to that line. And all these set of lines will actually form a plane, not a unique line. So we don't really have a Cartesian form of the equation. But in any case, I hope you understand this particular equation, which is called the parametric form of the equation for the line. And it is very helpful. You can find x-intercepts, y-intercepts, xy-intercepts, and so many things with this line, with this form of the equation. For example, if you have to find intercept of this line with xy plane, in that case z is 0. So you can equate z equals to 0 and find the value of t, which will be minus 3 over 20. And if you use that value of t here, you can find the xy plane, xy point, and therefore the intercept with xy plane. So that is how we can use this equation in different forms and apply it. I hope you understand and appreciate it. We do have an extension to this question, and we'll look into it in the next video. Thank you and all the best.